Your lead developer just pushed code that broke the main branch. Your security team is frantically emailing about a vulnerability in an open-source library you're using. And your CTO is asking why the team is spending more time managing permissions and wrestling with CI servers than actually shipping product. If any of this sounds familiar, you're not alone. This is the quiet chaos humming beneath the surface of thousands of development teams across the United States. It's the friction that slows down innovation, introduces risk, and burns out your best talent. We all start with the free version of GitHub. It's fantastic, revolutionary even. But there comes a point in every serious company's journey where the tools that got you here won't get you there. That point is when you have more than a handful of developers, when you're handling sensitive customer data, when you need to pass a SOC 2 audit, or when downtime isn't just an inconvenience, it's a massive financial liability. That's when you need to graduate from the public playground to the professional-grade secure fortress. That is the moment you need GitHub Enterprise. And over the next 10 parts, I'm going to give you the definitive playbook for mastering it. This isn't a boring feature-by-feature list you could just read in the documentation. This is a strategic guide, built specifically for US-based teams, designed to solve the very real problems you face every single day. We're going to show you how to lock down your intellectual property so tightly that your security team will actually smile. We'll build an automated, compliant, and lightning-fast development pipeline using GitHub Actions that will make your competition look like they're stuck in the dial-up era. We will give you the exact framework for managing permissions, access, and policies for hundreds of developers, so you can onboard a new engineer and have them securely contributing code in minutes, not days. By the end of this series, you won't just use GitHub Enterprise. You will wield it as a strategic weapon to ship better software, faster, and more securely than ever before. So let's start with the most fundamental question, the one that everything else is built on. What exactly is GitHub Enterprise and why should you care? At its core, GitHub Enterprise takes everything you love about GitHub, the pull requests, the issue tracking, the collaborative spirit, and wraps it in a hardened shell of security, compliance, and administrative control that is non-negotiable for any serious business. It's not just GitHub with a few extra buttons. It's a completely different platform philosophy. Think of it like this: the standard free version of GitHub is like living in a massive public apartment complex. It's great, it's functional, and you have your own space. But you share the infrastructure, the security guards are for the whole building, and you have to abide by the landlord's rules. GitHub Enterprise, on the other hand, is like being handed the keys to your own private, custom-built corporate campus. You control who comes in and out at the front gate. You have your own dedicated security force. You set the rules. You own the land, the buildings, and everything inside. This corporate campus comes in two primary flavors, and choosing the right one is the first critical decision your team will make. Your options are GitHub Enterprise Cloud and GitHub Enterprise Server. Let's break down GitHub Enterprise Cloud first. This is the most popular choice for a reason. It gives you all the power of enterprise, but it's hosted and managed by GitHub on their infrastructure. This is the best of both worlds option for many US companies. You get advanced security features like SAML single sign-on, which lets your team log in using the same corporate credentials they use for everything else. You get sophisticated team and user management, mandatory two-factor authentication, and detailed audit logs that show you exactly who did what, and when, something that is absolutely critical for compliance standards like SOC 2 or HIPAA. The huge advantage of Enterprise Cloud is simplicity. You don't have to manage any servers. You don't have to worry about updates, maintenance, or uptime. GitHub's world-class engineering teams handle all of that for you, so your team can focus on building your product, not managing your tools. For most fast-growing tech companies, startups with fresh funding, and established businesses looking to modernize their stack without taking on massive operational overhead, Enterprise Cloud is the default, go-to answer. It delivers 90% of the control with 0% of the infrastructure headache. But what about that other 10%? What if your company has requirements that are so strict, so specific, that you cannot allow your source code, your company's crown jewels, to live on any server that you don't physically control? This is where GitHub Enterprise Server comes in. Enterprise Server is the ultimate solution for maximum control. With this option, you get the entire GitHub platform as a software appliance that you install and run on your own infrastructure. This could be in your own on-premise data center or on your private cloud account, like AWS, Azure, or Google Cloud. You have complete and total authority. Your code never leaves your network. This is the choice for organizations in highly regulated industries. We're talking about major financial institutions on Wall Street that have to meet stringent SEC regulations. We're talking about healthcare companies that handle patient data and must be HIPAA compliant. And critically, we're talking about government contractors and federal agencies that need to operate in an air-gapped environment or meet extreme compliance standards like FedRAMP. With Enterprise Server, you can literally unplug the network cable to the outside world, and your team can continue to work, collaborate, and build within your own secure, isolated ecosystem. The trade-off, of course, is responsibility. With Enterprise Server, your team is now responsible for provisioning the hardware, installing the software, managing backups, applying security patches, and handling updates. It requires a dedicated team with infrastructure expertise. It's a significant commitment, but for companies where data sovereignty and absolute control are paramount, it's the only option. So how do you choose? It boils down to a simple question. What is your primary constraint? Is it speed and operational efficiency? Or is it absolute control and regulatory compliance? If you're a high-growth SaaS company in San Francisco, a digital agency in New York, or a remote-first tech company building the next big thing, your primary constraint is likely speed. You need to empower your developers, not bog them down with infrastructure. You need to be agile. For you, GitHub Enterprise Cloud is almost certainly the right answer. It gives you the security and management features you need to scale responsibly without slowing you down. If you're a defense contractor in Virginia, a bank in Charlotte, or a biotech firm in Boston handling proprietary genetic data, your primary constraint is control and compliance. The risk of your intellectual property leaving your network is unacceptable. You have auditors and regulators to answer to. For you, the operational overhead of GitHub Enterprise Server is not a burden. It's a necessary cost of doing business securely. Understanding this fundamental difference between cloud and server is the first step. It's the foundation upon which every other decision you'll make about your development ecosystem will be built. Get this right and you're setting your team up for success. Get it wrong and you're creating a world of friction, risk, and technical debt down the road. In the next part, we're going to dive deep into the first pillar of enterprise, security. We'll move beyond the theory and show you the exact tactical steps to configure your organization to be virtually impenetrable. So, how do we build that fortress? How do we take a standard GitHub organization and transform it into a secure, enterprise-grade environment that lets your developers move fast without compromising on safety? It starts with a foundational concept: identity. Who has access to your code and how do you prove they are who they say they are? For any US-based company, especially those in regulated industries, managing hundreds or thousands of developer accounts individually is a non-starter. It's inefficient and a massive security risk. This is where your first critical configuration comes into play: single sign-on or SSO, specifically using the SAML standard. Think of SAML SSO as the master keycard system for your entire digital office. You don't give every employee a separate key for every single door. You give them one keycard, managed by a central security office, that grants them access to only the doors they're authorized to open. In our world, that central security office is your identity provider, or IDP. This is probably a tool you already use like Okta, Microsoft Azure Active Directory, or Ping Identity. By integrating your IDP with GitHub Enterprise, you establish a single source of truth for who is in your organization. When a new developer joins your company, you add them to the correct group in Okta or Azure AD. They're automatically provisioned a GitHub account and given the right access. There's no manual invitation, no waiting for an admin, no chance for human error. But here's the most critical part, the part that lets CTOs and security officers sleep at night. When that developer leaves the company, and you deactivate their account in your central IDP, their access to GitHub is instantly and automatically revoked. This is huge. The nightmare scenario of a disgruntled ex-employee still having access to your company's source code is one of the most common security vectors. With a proper SSO integration, that entire risk category is virtually eliminated. This automatic provisioning and deprovisioning is handled by a protocol called SCIM, which stands for System for Cross-Domain Identity Management. When you enable both SAML and SCIM, you're not just logging in securely, you're automating the entire lifecycle of a user's identity within GitHub, perfectly synchronized with your company's official employee roster. Now, a verified identity is great, but it's only one half of the equation. The other half is ensuring that identity hasn't been compromised. That's where you, as the administrator, need to make a firm decision. You must enforce two-factor authentication for every single member of your organization. This is not optional. It's not a suggestion you send in a memo. Within your GitHub Enterprise settings, you can check a box that says Require two-factor authentication for everyone. Do it. This single action dramatically increases your security posture. A compromised password alone is no longer enough to breach your organization. An attacker would also need the employee's physical phone or a hardware security key. Speaking of which, while app-based authenticators are good, encourage your teams to use hardware security keys like a YubiKey. They are the gold standard, resistant to phishing attacks that can sometimes fool even savvy users of authenticator apps. For any organization dealing with sensitive intellectual property or compliance frameworks like SOC 2 or HIPAA, mandatory 2FA isn't just a best practice, it's a fundamental requirement. Okay, so we've locked down who can get in. Now we need to define what they can do once they're inside. This is the pillar of policy and governance. The guiding principle here is the concept of least privilege. People should only have the minimum level of access they need to do their jobs. Inside your organization settings, you'll find base permissions. By default, this might be set to write. This means any new member of your organization can push code to any repository they're added to. I'd argue for a more secure default. Change this to read. This way, new members can see code, clone it, and open issues, but they can't push changes without being explicitly granted write access on a per repository or per team basis. It's a simple switch that forces a more intentional approach to granting permissions. Next, let's talk about repository creation. Who can create new repositories? Can they make them public? An accidental public repository containing proprietary code or secrets is a 5-alarm fire. You need to lock this down. You can set policies to prevent members from creating public repositories at all, or limit creation to only private or internal repositories. Internal repositories are a fantastic feature of Enterprise, allowing code to be shared openly within your company, but remaining completely invisible to the outside world. Set sane defaults here. For most companies, disabling the creation of public repositories by general members is a wise first step. With identity and basic permissions set, we move to the most powerful governance tool at your disposal: branch protection rules. This is where you enforce your team's development workflow directly within GitHub, creating digital guardrails that make it impossible to cut corners. Let's say your most important branch is called main. You should immediately set up a protection rule for it. Here are the non-negotiable settings you need to enable. First, require a pull request before merging. This single rule eliminates direct pushes to your main branch. All changes must go through a PR, creating a documented, reviewable history for every line of code that gets deployed. Second, require approvals. Set this to at least 1 and preferably 2 for critical repositories. This enforces peer review. A developer can't just merge their own code into production because they're in a hurry. Someone else has to look at it and sign off. You can even use a code owner's file to automatically request reviews from the specific team responsible for that part of the code. Third, require status checks to pass before merging. This is the voice of your automation. This rule connects GitHub to your CI/CD pipeline, tools like Jenkins, CircleCI, or GitHub Actions. It means you can't merge a pull request unless the code builds successfully, the automated tests all pass, and the vulnerability scans come back clean. This prevents broken code from ever reaching your main branch. Fourth, require signed commits. This is a more advanced, but incredibly valuable feature. It uses GPG or SSH keys to cryptographically sign every commit, proving that it was made by a specific, verified developer. This protects against a sophisticated attack where someone might try to impersonate one of your developers and inject malicious code. For teams with high security requirements, especially those working on projects for government contracts under frameworks like FedRAMP, this is often a mandatory control. By combining these rules, you create an ironclad workflow. To get code into the main branch, a developer must create a pull request, get it approved by a teammate, have all the automated checks pass, and do it all with signed commits. You've just built a quality and security gate that works 24/7 automatically. Finally, we have the third pillar, auditing and monitoring. You've set up the locks and the rules. Now you need the security cameras to see what's happening. This is the audit log. GitHub Enterprise provides an incredibly detailed, exportable audit log that records virtually every action taken across your organization. A user was added to a team? It's in the log. A repository was deleted? It's in the log. A deploy key was added? It's in the log. This is your organization's immutable black box recorder. When a security incident occurs, this is the first place you'll go to answer the questions: who, what, where, and when. But you can be proactive. You can stream this audit log to a monitoring service like Splunk or Datadog. There, you can set up automated alerts for high-risk activities. For example, you can create an alert that pages your security team if a repository is changed from private to public, or if two-factor authentication is disabled for any account, or if a new SSH key is added to a highly privileged user. This moves you from reactive forensics to proactive defense, catching suspicious behavior the moment it happens. By deliberately configuring these three pillars: identity, policy, and auditing, you transform GitHub from a simple code hosting platform into a managed, secure, and compliant development environment. You're not just storing code. You're safeguarding your company's most valuable asset. Now that we've locked the doors, set the house rules, and turned on the cameras, what about the sensitive information we might be leaving inside the house? What about the API keys, the database credentials, and the private certificates accidentally committed directly into our source code? And what about the vulnerabilities in the open source packages we depend on? Securing the perimeter is one thing, but securing the code itself is a whole other challenge. That's where we need to bring in the heavy artillery: GitHub Advanced Security. GitHub Advanced Security isn't just one tool. It's a native security suite built directly into the GitHub platform. Think of it as a three-layered shield for your code. It's designed to find vulnerabilities before they ever make it into production, embedding security directly into the developer's workflow. This is the essence of what the industry calls shifting left, moving security from the end of the line, where it's slow and expensive, to the very beginning, where it's fast, cheap, and effective. The first layer of this shield is code scanning, powered by a truly revolutionary engine called CodeQL. Now, you might have heard of static analysis tools before. They read your code and look for potential problems. But CodeQL is different. It doesn't just read your code, it treats your code as data. It builds a complete database representation of your code base, and then runs sophisticated queries against it. Imagine trying to find a needle in a haystack. A traditional tool might sift through the hay piece by piece. CodeQL, on the other hand, turns the entire haystack into a searchable map, highlighting every single piece of metal. It understands the flow of data through your application. It can trace a piece of user input from a web form, through multiple functions and libraries, all the way to a database query. This is how it uncovers incredibly complex vulnerabilities like SQL injection, cross-site scripting, and remote code execution that are nearly impossible for a human to spot in a manual code review. Let me tell you about a team at a mid-sized fintech company in Chicago. They had a rigorous peer review process. 2 senior engineers had to sign off on every pull request. They were confident in their code quality, but when they enabled CodeQL, it flagged a critical vulnerability in a legacy part of their payment processing module. Tainted data from an obscure API endpoint could, under very specific circumstances, be used to manipulate a database query. It was a ticking time bomb. The team estimated it would have taken a dedicated security researcher weeks to find this. CodeQL found it in under 10 minutes during a pull request. That's the power we're talking about. It's not just another linter. It's like having a world-class security research team embedded in your development process. Now, for the second layer of the shield, secret scanning. This one addresses a problem that is painfully common and universally terrifying. A developer working late on a Friday trying to push a fix before the weekend accidentally commits an API key, an AWS secret key, a database connection string, a private token for a third-party service. It happens. It's a simple mistake, a copy-paste error. But the consequences can be catastrophic. Malicious bots are constantly scanning public GitHub commits for exactly these patterns. Within seconds of that commit being pushed, your cloud infrastructure could be compromised, your data exfiltrated, your company facing a massive breach. Secret scanning is your automated safety net. It scans every single push in real time for patterns that match known secret formats from dozens of service providers. If it finds a potential secret, it doesn't just flag it. It immediately notifies the developer and the organization's security team. But here's the game changer for enterprise users. GitHub has partnerships with major cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud. When secret scanning detects one of their keys, it can automatically trigger a notification to the provider, who can then immediately revoke that key, closing the window of opportunity for an attacker before it even truly opens. It turns a potential company-ending disaster into a non-event, A simple learning moment for a developer. This isn't just a nice to have. For any US company handling sensitive customer data, this is an absolute necessity. That brings us to the third and final layer, dependency security. Let's be honest, no one builds software from scratch anymore. Modern applications are built on the shoulders of giants, the vast ecosystem of open source packages and libraries. Your average enterprise application can have hundreds, even thousands of these dependencies. Each one of those is a potential attack vector. You might have written the most secure code in the world, but if you're using a logging library with a vulnerability like Log4j, your entire fortress can come crumbling down. This is the software supply chain problem. GitHub Enterprise tackles this head-on. It starts with Dependabot, which automatically scans your dependency files, your package.json, your pom.xml, your requirements.txt, and checks the versions you're using against a massive database of known vulnerabilities. If it finds one, it doesn't just tell you there's a problem. It automatically opens a pull request to update the package to a safe version, complete with release notes and compatibility scores. It does the work for you. But advanced security takes it a step further with the dependency review. This happens inside the pull request itself. When a developer tries to add a new dependency or change the version of an existing one, GitHub will show a clear diff of what's changing. It will tell you the license of the new package, preventing accidental legal issues. And most importantly, it will tell you if that new version introduces any known security vulnerabilities before you merge the code. It's like having a security expert and a lawyer review every single open source component you bring into your project. It helps you build a clean software bill of materials, or SBOM, which is increasingly a requirement for doing business with the US government and other large enterprises. So let's put it all together. A developer writes new code and opens a pull request. Instantly, three things happen. 1. Code scanning with CodeQL analyzes the new code itself, looking for vulnerabilities like SQL injection. 2. Secret scanning checks to make sure no passwords or API keys were accidentally included. 3. Dependency review checks that any new or updated open source packages are secure and properly licensed. All of this information is presented directly within the pull request interface. It's not in some separate dashboard that developers have to remember to check. It's right there in their daily workflow. You can even configure branch protection rules that prevent a pull request from being merged if it has critical security alerts. This changes the entire culture of development. Security is no longer an afterthought, a gatekeeper at the end of the process. It becomes a shared responsibility, a baked-in part of writing good code. For US-based teams, especially those in regulated industries like finance, healthcare, or government contracting, this isn't just best practice, it's a requirement for compliance. Having this auditable, automated security trail built into your development process is critical for passing audits like SOC 2 or achieving FedRAMP authorization. GitHub Advanced Security transforms your repository from a simple version control system into an active, intelligent defense system. It's about building security and not bolting it on. It protects you from your own mistakes, from mistakes in your dependencies, and from the sophisticated attacks targeting modern applications. We've effectively locked down the code itself. But writing secure code is only one part of the equation. How do we ensure that this secure code is built, tested, and deployed in a way that is just as secure, reliable, and most importantly, automated? How do we build the superhighway that takes this code from a developer's laptop to our customers without any manual tolls or dangerous potholes? That requires a robust CI/CD pipeline, and that's where we turn to the engine of the entire GitHub platform, GitHub Actions. GitHub Actions is the automated assembly line at the heart of your software factory. It's the engine that powers that superhighway we just talked about. Before we dive into the nuts and bolts, the workflows, the runners, the events, let's address the ghost in the machine for so many US companies, the old way of doing things. For years, continuous integration and continuous delivery, or CI/CD, felt like a necessary evil. It was a Frankenstein's monster of disparate tools. You had your code over here in GitHub, but the moment you pushed it, it was thrown over the wall to a completely separate system. Often, this was a rickety, aging Jenkins server, humming away in a forgotten corner of a data center, maintained by one or two people who became accidental and often unwilling experts. We've all known that person, the Jenkins janitor. Their job wasn't to innovate. It was to spend half their week just keeping the lights on, updating plugins, untangling brittle scripts, and explaining to frustrated developers why their build failed for the 10th time due to some obscure configuration drift. The cost of this context switching is immense. Your developers, your most valuable asset, are forced to leave the platform where they live and breathe, GitHub, to decipher a completely different UI, a different set of logs, a different permission model, just to figure out what happened to their code. It's inefficient. It's expensive. And frankly, it's a security and compliance nightmare. Who has access to that build server? Is it patched? Are the credentials it uses to deploy to production stored securely? For many organizations, the honest answer is we're not entirely sure. And that is a terrifying answer to give an auditor. GitHub Actions was built to kill this complexity. It's not a separate tool bolted on. It's woven into the very fabric of the GitHub platform. The idea is simple but revolutionary. The same place you store your code, review your code, and manage your projects should also be the place you build, test, and deploy your code. So how does it work? Let's stick with our assembly line analogy. The entire blueprint for your automation is called a workflow. This is a simple text file, written in a format called YAML, that lives right inside your repository, alongside your code. This is huge. Your automation is now version controlled. You can review changes to your deployment process in a pull request, just like you'd review a change to your application's source code. The blueprint itself is now part of the product. An event is the trigger that starts the assembly line. This could be anything: a developer pushing code to a specific branch, a new pull request being opened, even a scheduled time, like running a report every Monday at 9 a.m. Or it can be a manual trigger, a big green button a project manager can press to deploy to a staging environment. The flexibility is nearly infinite. Once the event happens, the workflow starts one or more jobs. A job is a major station on our assembly line. You might have a build station, a test station, and a deploy station. By default, these stations run in parallel, like building the car's chassis and engine at the same time to be more efficient. But you can also configure them to run sequentially, ensuring you only move to the test station after the build station has successfully completed. Inside each job, you have steps. These are the individual commands, the specific robotic arms performing a single task at that station. A step might be check out the code, install the dependencies, run the unit tests, or log in to our cloud provider. It's a sequence of precise atomic operations. And this is where the magic really happens. Many of these steps are powered by actions. An action is a prepackaged, reusable piece of automation. Think of it as a specialized, off-the-shelf tool for your assembly line. You don't need to write a custom script to check out your code. You just use the official checkout action. You don't need to figure out the complex command line gymnastics to log into Amazon Web Services, Azure, or Google Cloud. You use their officially supported login actions. The GitHub Marketplace is a treasure trove of thousands of these actions, built by the community and by vendors. Need to send a Slack notification? There's an action for that. Need to scan your container image for vulnerabilities? There's an action for that. This fundamentally changes the game. Your team is no longer writing boilerplate automation scripts from scratch. They are composing powerful workflows by connecting these battle-tested, pre-built components. Finally, all of this work has to happen somewhere. The physical machines that run your jobs are called runners. GitHub gives you fully managed runners out of the box. Think of this as renting a pristine, ready-to-go spot on a massive shared factory floor. For public projects and many standard private projects, this is perfect. They're secure, they're maintained by GitHub, and you get a fresh, clean virtual machine for every single job, eliminating any chance of one build interfering with the next. But for a US-based enterprise, this is where GitHub Enterprise provides a critical superpower: self-hosted runners. This is the feature that allows you to move from renting a spot on the public factory floor to building your own private, secure, state-of-the-art manufacturing plant. A self-hosted runner is a machine that you control, running the GitHub Actions agent. It can be a virtual machine in your private AWS VPC or Azure VNet. It can be a physical server sitting in your on-premises data center. Can be anything. Why is this so important? 3 key reasons: compliance, security, and performance. First, compliance. If you're a government contractor dealing with FedRAMP requirements, or in healthcare handling data under HIPAA, you often cannot have your build process touching the public internet. With self-hosted runners, your code never leaves your network boundary. The runner pulls instructions from GitHub, but the source code, the build artifacts, the secret keys, it all stays within your secure, audited environment. Second, security. You can equip your self-hosted runners with specific firewall rules, IAM roles, and network access policies. You can ensure they can only talk to your private artifact repository or your production database cluster, drastically reducing your attack surface. It's the difference between using a public loading dock and having a private, access-controlled bay where only your trusted trucks are allowed. And third, performance and customization. What if your build process requires a massive amount of RAM? Or what if you're training a machine learning model and need a powerful GPU? With self-hosted runners, you control the hardware. You can provision machines with the exact specifications you need, leading to faster, more efficient builds. You can install custom software, certificates, or drivers that are unique to your company's environment. This combination of a simple code-based workflow definition and the enterprise-grade power of self-hosted runners is what makes GitHub Actions so transformative. You can create standardized, reusable workflows that enforce your company's best practices for security and deployment, and then allow teams to execute those workflows on runners that meet the strictest compliance and performance requirements. So now we have this incredible automated assembly line. It's checking our code, running tests, and ensuring everything is built perfectly, securely, and in compliance with our policies. But an assembly line produces a finished product. In our case, that product is often a software package, a Docker container, a Java JR file, a Node.js package. Where do these finished products go? How do we store, version, and distribute them so other teams and other applications can use them? Shoving them into a random file share or a public registry just isn't an option. We need a secure, private, and integrated warehouse for our software goods. And that warehouse is called GitHub Packages. It's the digital equivalent of a shared workshop where nobody labels their tools. One team builds a fantastic new component, a universal authentication library, let's say. It's brilliant. It's robust. They use it in their project and it works flawlessly. Then another team hears about it. Hey, can we use that auth library? It would save us weeks of work. Sure, says the first team. It's over here on this network drive. And right there the chaos begins. A week later, the first team finds a small bug in their library. They fix it, recompile the package, and overwrite the old file on the network drive. They forget to tell anyone. The second team, in the middle of a critical pre-release build, suddenly finds their application crashing. Nothing they did broke it. They spend hours, maybe days, debugging, pulling their hair out, only to discover that the fundamental tool they were relying on was swapped out from under them without their knowledge. This isn't a hypothetical. This is the reality of dependency management without a central version-controlled system. It's inefficient, it's risky, and in a professional US enterprise environment, it's downright unacceptable. GitHub Packages solves this. It's not just a place to store files. It's a dedicated, fully integrated package registry built right into the GitHub platform you already use. Think of it as your company's private, secure app store for code. Whether you're building NuGet packages for a .NET application, JR files with Maven for a Java backend, Docker images for your microservices, or like in our example, a package for a Node.js project, GitHub Packages provides a single, reliable home for them. Let's walk through how this completely transforms the broken workflow we just described. Our first team has just finished version 1.0.0 of their Innovate Auth library. Instead of dropping it on a shared drive, they're going to publish it to GitHub Packages. The process is incredibly simple and designed to fit right into a developer's existing toolkit. First, they need to authenticate. This isn't some shared username and password. This is handled through a personal access token, or PAT. A developer generates a token in their GitHub settings, giving it a very specific scope, in this case the right packages permission. This token is then configured in their local environment. For an NPM project, this means adding a couple of lines to a local.npmrc file, telling Node's package manager, hey, for any packages that belong to our organization, don't go to the public NPM registry. Go to GitHub's registry instead, and use this token to prove who you are. This is a critical security point. Access is granular and revocable. If an employee leaves the company, you just revoke their tokens. You're not chasing down shared passwords. The authentication is tied to their GitHub Enterprise identity, which is likely already managed by your company's single sign-on system. With authentication configured, publishing is a single command they already know, npm publish. That's it. Because of the .npmrc configuration, npm knows exactly where to send the package. It gets securely uploaded, versioned, and stored within your GitHub organization's private space. The package is now intrinsically linked to the source code repository that built it. You can go to the Repositories main page and see a Packages link right there. Click it and you'll see Innovate Auth version 1.0.0, along with download statistics, version history, and a direct link back to the exact source code that created it. The chain of custody is unbroken. Now let's look at the second team, the consumers. Their experience is just as seamless. They also configure their .npmrc file to point to the GitHub Packages registry for their organization. They don't need write access, just read access, so their personal access token can be scoped more tightly for even better security. Once that one-time setup is done, using the package is as simple as any other public package. They just run npm install at /innovateauth. And here's the magic. A few weeks later, when the first team discovers that bug, they fix it, bump the version number to 1.0.1 in their package.json file, following standard semantic versioning, and they run npm publish again. A new separate version of the package is uploaded. It doesn't overwrite the old one. The second team is completely unaffected. Their project is still locked to version 1.0.0. Their builds are stable. They don't get a nasty surprise. Later, when they're ready to upgrade, they'll see that a new version is available. They can read the release notes, check the commit history, and make a conscious, informed decision to update by running npm install at /innovateauth at 1.0.1. They are in control. The chaos is gone, replaced by order and predictability. This is a game changer, but it gets even better when you think about the enterprise scale. We talked about npm, but this same workflow applies across your technology stack. Your Java developers can publish their jars and POM files to the Maven registry within GitHub Packages. Your DevOps engineers can push their production-ready Docker images to a container registry that lives right alongside the Docker file that created it. Your C# developers can share their libraries via a private NuGet feed. This eliminates tool sprawl. You no longer need to pay for and manage separate, third-party services like a private Docker hub, a self-hosted Nexus or Artifactory for Maven, and so on. It's all consolidated. One security model, one set of permissions, one user interface, all integrated. This simplifies administration, reduces costs, and lowers the cognitive overhead for your developers. They don't have to learn 5 different ways to publish and consume artifacts. They learn one. And the integration with the rest of GitHub Enterprise is where the true power is unlocked. Permissions are a perfect example. You can control access to packages using the same GitHub teams you use to control access to your code. You could have a rule that says, only members of the core infra team can publish new versions of our base Docker images. Or, any developer in the organization can read our shared UI components package, but only the UI platform team can write to it. This level of granular control is essential for maintaining stability and security in a large organization. It ensures that only authorized code from authorized individuals makes its way into your shared ecosystem. This brings us to the ultimate force multiplier: automation with GitHub Actions. Manually running npm publish is great, but it's still a manual step. It's something a developer has to remember to do. But what if we could make it completely automatic, triggered by the development process itself? Imagine this workflow. A developer on the InnovateAuth team finishes their bug fix. They open a pull request. Their code gets reviewed by a colleague and all the required automated checks pass. Finally, the pull request is approved and merged into the main branch. The moment that merge happens, a GitHub Actions workflow automatically kicks off. It checks out the latest code, runs the build and test suite one last time, and if everything passes, it automatically bumps the package version, and then, using a special GitHub_token that requires 0 manual setup, it publishes the new shiny version 1.0.2 of the package directly to GitHub Packages. The entire process is hands-free, error-proof, and perfectly audited. The developer who wrote the code doesn't need to have publish permissions on their personal account. The action does it for them securely. This is the foundation of a modern mature CI/CD, or continuous integration, continuous delivery pipeline. It's about creating a frictionless path from a developer's keyboard to a reusable, versioned, and secure software artifact. By using GitHub Packages, you're not just storing bits and bytes. You're creating a single source of truth for your organization's compiled assets. You're breaking down silos between teams, enabling them to share and reuse code safely and efficiently. You're enhancing your security posture by centralizing control and visibility. And you're laying the groundwork for powerful automation that accelerates your development lifecycle. So our package is published, versioned, and secure. Our teams can collaborate without stepping on each other's toes. But a package sitting in a registry isn't delivering value to customers. a component, a building block. It needs to be integrated, tested, and ultimately deployed into a running application. And that's where the real automation powerhouse of GitHub Enterprise comes into play: GitHub Actions. GitHub Actions is more than just a feature. It's a fundamental shift in how we think about our software lifecycle. It's the automation engine built directly into the heart of your development process, living right alongside your code. Think about it: for years our build scripts, our deployment logic, our testing harnesses, they were often scattered. They were shell scripts on a dedicated Jenkins server in the corner, a collection of plugins with their own update cycles, or worse, a series of manual steps written in a dusty wiki that everyone was afraid to touch. GitHub Actions changes the game by treating your automation as what it truly is: code. Your entire CI/CD pipeline, from the moment you push a commit to the second it's deployed to production, is defined in a simple text file, a YAML file, that lives right inside your repository. This is a concept we call pipelines as code, and it is a massive unlock for enterprise teams. Your automation is now versioned. It's reviewable. It's auditable. When you roll back your application code to a version from 6 months ago, you can also roll back the exact build and deployment process that was used for it. That's a level of consistency and repeatability that a lot of teams can only dream of. So, how does it actually work? Let's break it down. The core concept is a workflow. A workflow is an automated process that you define. It's triggered by a specific event in your repository. That event could be anything: a push to a branch, the creation of a pull request, a new issue being filed, or even on a schedule like running a report every Monday at 9 a.m. Inside each workflow, you have one or more jobs. Jobs are sets of steps that execute on the same runner. A runner is simply a server, a virtual machine that's going to execute your job. You can think of a workflow as the entire assembly line, and each job is a specific station on that line. Maybe the first station is assemble the parts, the second is run quality control, and the third is package for shipping. They can run in parallel to save time, or you can make them dependent on each other, so the packaging station doesn't start until quality control gives the green light. And inside each job, you have steps. Steps are the individual commands or actions that get executed. This is where the work actually gets done. A step can be as simple as running a single command line script, like npm install to install your dependencies, or mvn clean install to build a Java project. But the real magic, the secret sauce of GitHub Actions, is the concept of, well, actions. An action is a reusable packaged piece of code that does a specific task. You don't have to write a script to check out your repository source code. There's an official action/checkout action for that. You don't have to write a complex script to set up a specific version of the Java development kit or Node.js on your runner. There are actions/setup Java and actions/setup Node for that. This is powered by the GitHub Marketplace, which is essentially an app store for your CI/CD pipelines. Thousands of companies and individual developers have created actions for everything you can imagine: logging into AWS, Azure, or Google Cloud, building and pushing a Docker container, sending a notification to Slack, running a security scan with SonarQube. This means you're not starting from scratch. You are assembling your pipeline from battle-tested, community-vetted building blocks. This dramatically accelerates how quickly your team can build robust, powerful automation. Now let's talk about those runners, the servers where your jobs actually run. GitHub Enterprise gives you two powerful options, and for US-based companies, especially those in regulated industries like finance, healthcare, or government contracting, this choice is critical. First, you have GitHub-hosted runners. These are virtual machines that GitHub manages for you in the cloud. They come preloaded with a ton of common software and tools, and they're available in various sizes, from standard Linux machines to larger Windows or even macOS runners for building iOS apps. The beauty of these is their simplicity. You just specify runs on Ubuntu latest in your workflow file, and GitHub spins up a fresh, clean VM for your job, runs your steps, and then tears it down. It's completely ephemeral and isolated. For teams building standard web apps or services that don't have complex infrastructure dependencies, this is often the fastest way to get started. But for many enterprises, this isn't enough. What if your build process needs to access a database that's locked down inside your private corporate network? What if you need specialized hardware like a powerful GPU for a machine learning model training pipeline? What if your company policy dictates that no source code can ever be processed on third-party infrastructure, even for a few minutes? This is where the second option comes in: self-hosted runners. With GitHub Enterprise, you can install the runner agent on any machine you control, whether it's a virtual machine in your own data center, a server in your private AWS VPC, or even a physical machine under a desk. You register it with your GitHub Enterprise organization, and now you have a pool of private, dedicated runners that only your workflows can use. This is a game changer. You get the best of both worlds. The slick, integrated workflow orchestration of GitHub Actions, combined with the complete control, security, and performance of your own infrastructure. You can create runners with specific software pre-installed to speed up your builds. You can give them access to internal artifact repositories, secret vaults, and private networks. For U.S. companies dealing with ITAR, HIPAA, or FedRAMP compliance, the ability to ensure the entire CI/CD process runs on trusted, company-controlled hardware is not just a feature, it's a requirement. Let's walk through a tangible example of a continuous integration or CI workflow. Imagine a developer on your team opens a new pull request. As soon as that happens, a workflow is triggered. The workflow file specifies a job called build-in test. It's configured to run on a GitHub-hosted runner. The first step uses the actions/checkout action to pull the source code into the runner. The second step uses the actions/setup node action to install the specific version of Node.js your project requires, ensuring a consistent environment every single time. The third step runs npm CI to install the exact dependencies from your lock file. The fourth step runs npm run lint to check for code style issues. The fifth step runs npm run test to execute your entire suite of unit tests. As these steps run, the output is streamed in real time to the Actions tab in the GitHub UI. The developer can watch the logs as if it were running on their own terminal. If any step fails, if a linter rule is violated or a unit test breaks, the entire job fails. And here's where it all ties together. Back on the pull request page, a status check appears. It's no longer just a conversation between humans, the machine is now part of the review. A red X appears next to the failing check, clearly signaling to the developer and any reviewers that this code is not ready. It prevents works on my machine syndrome, because the build is happening in a neutral, standardized environment. It enforces quality automatically, before a human reviewer even needs to spend time looking at the logic. This simple CI workflow is the foundation. It's the safety net that catches bugs early. It's the automated gatekeeper that ensures a baseline of quality for every single change. By embedding this automation directly into the pull request, the central hub of collaboration, GitHub Actions transforms your development process from a series of manual, error-prone steps into a streamlined, reliable, and efficient factory for producing high-quality software. The green checkmark on a pull request becomes a symbol of trust. It tells the team, not only have I, the developer, tested this, but our automated process has built it from scratch, validated it, and confirmed it meets our standards. It elevates the entire code review conversation, allowing reviewers to focus on the important things, the architecture, the logic, the business value, instead of worrying if they forgot to run a test. But getting that green checkmark is just the beginning. The code is merged. It's on your main branch. It's tested, it's clean, it's ready. But it's not delivering any value yet, because it's not in the hands of your users. How do we close that last mile? How do we take this validated code and get it deployed to a staging environment, or even into production, in a way that is secure, auditable, and controlled? That's the world of continuous deployment, and it requires another level of tools. You need a way to manage different environments, handle sensitive credentials like cloud API keys and database passwords, and enforce manual approvals for critical deployments. And that is precisely where GitHub Actions environments and secrets come into play. So let's paint a picture. It's late on a Friday. A critical hotfix needs to go out. The workflow is triggered, tests pass, and the deployment script runs. But there's a small, almost invisible mistake in the workflow file. Instead of using the production database credentials, it's using the staging credentials. Or worse, it deploys the staging build to the production environment. It's a silent failure that can lead to catastrophic data corruption, downtime, and a weekend spent in a war room. This isn't a hypothetical horror story. It's a scenario that keeps engineering managers up at night. The core problem is a lack of separation and control. When your CI/CD process treats staging and production as just slightly different sets of variables, you're building on a foundation of risk. This is exactly the problem GitHub Actions environments are designed to solve. Think of an environment not just as a label, but as a fortified vault for a specific deployment target. You might have a development vault, a staging vault, and a high-security production vault. Each vault has its own distinct set of rules, its own access controls, and its own unique set of secrets. By formalizing these deployment targets within GitHub, you move from relying on convention and careful scripting to relying on enforced, auditable policy. Let's start with the most powerful feature: environment protection rules. This is where the magic happens. Imagine you want to ensure that no code ever reaches your production servers without explicit approval from a senior engineer or a project manager. Without environments, you'd be building custom Slack bots or convoluted manual processes. With environments, it's a checkbox. You can configure the production environment to require a review from a specific person or a team. When a workflow attempts to deploy to that environment, it automatically pauses. It literally stops in its tracks. The designated reviewers get a notification right within GitHub. They can look at the code that's about to be deployed, review the test results, and then with a single click, approve or reject the deployment. If they approve, the workflow resumes. If they reject, it fails. This creates an unbreakable, fully auditable chain of custody. For any company in the US dealing with compliance standards like SOC 2 or HIPAA, this isn't just a feature, it's a requirement. You have a built-in timestamped record of who approved every single deployment to your most critical environment. But it doesn't stop there. Another simple but brilliant protection rule is the wait timer. We've all seen it. A developer pushes a fix, it breaks something, so they quickly push another fix and another. A rapid succession of deployments can sometimes cause more chaos than the original problem. You can configure a wait timer on your production environment, say for 10 or 30 minutes. This forces a cooldown period between deployments, giving your monitoring systems time to report any issues from the previous release and preventing panicked, back-to-back pushes. It's a simple speed bump that can save you from a major pileup. And perhaps the most fundamental rule is specifying deployment branches. You can declare that only the main branch, or branches matching a pattern like release/*, are allowed to deploy to the production environment. This single rule eradicates an entire class of errors. A developer can't accidentally trigger a production deployment from their personal feature branch. The workflow will fail before it even starts, telling them they're trying to deploy from an unauthorized source. It's a guardrail that makes your process fundamentally safer. Now let's talk about the other half of this equation: secrets. For years, the standard practice was to store all your secrets at the repository level. You'd have staging under Your repository secrets list would get bloated and confusing, and your deployment scripts needed complex logic to figure out which secret to use based on the branch name. It was messy and error-prone. Environment-level secrets completely changed the game. You can now define a secret with the exact same name in different environments, but with different values. So you create a secret called database_URL in your staging environment and give it the value for your staging database. Then you go to your production environment and create a secret also named database_URL, but this time you give it your production database connection string. Now look at your workflow file. The code that uses the secret doesn't change at all. It simply references secrets.database_URL. The magic is in how you tell the job which environment to target. You just add a single line to your workflow job: environment, production. That's it. When GitHub Actions runs this job, it sees that it's targeting the production environment. It then automatically reaches into the production vault, pulls out the value for database_URL stored there, and makes it available to your script. If you were deploying to staging, you just change that one line to environment staging, and it would automatically use the staging-specific secret. Your scripts become cleaner, simpler, and infinitely safer. There's no chance of accidentally grabbing the production key for a staging deployment because the staging job literally does not have access to the production secrets. They are completely isolated in their own secure vaults. Let's walk through setting this up. It's shockingly simple. In your repository, you go to Settings, and on the left-hand side, you'll see Environments. You click New Environment, name it Production, and click Configure. Immediately, you're presented with the protection rules. You check the box for Required Reviewers, and type in the GitHub username or team name of your release manager. Then you check Deployment Branches and set it to Selected Branches, specifying only your main branch. You hit Save. Next, at the bottom of that environment's configuration page, you see Environment Secrets. You click Add Secret, name it API_key, and paste in your production API key. You repeat the process, creating another environment called Staging. This time, you don't add any protection rules because you want your team to be able to deploy to staging freely. But you do add an environment secret, also named API_key. And this time you paste in the separate key for your staging services. Now, in your workflow YAML file, you define 2 jobs. One job is for staging and it has the line environment, staging. The other job is for production and it has the line environment, production. Both jobs use the exact same deployment script, which references secrets.it_. When a developer merges a pull request into main, the workflow kicks off. The staging job runs immediately, deploying the new code to your staging server using the staging API key. Then the production job starts. But it doesn't run. It pauses, its status showing as waiting. Your release manager gets a notification. They review the changes, see that everything looks good on the staging site, and click Approve and Deploy. Only then does the job resume. It pulls the production API key from the production environment's vault and safely deploys to your production servers. You've just built a deployment pipeline that is secure, compliant, and dramatically reduces the risk of human error. You've separated your concerns, protected your most critical assets, and created an auditable, professional release process. This isn't just an add-on. It's a fundamental shift in how you manage your software delivery lifecycle, moving from fragile convention to robust configuration. It's the difference between a rickety wooden bridge and a steel-reinforced drawbridge with a gatekeeper. By leveraging environments and secrets, you're not just automating tasks. You're orchestrating a secure and reliable pathway from code to customer. But this pathway is only as secure as the code that travels along it. Protecting the deployment is one thing, but what about finding and fixing vulnerabilities in the code long before it ever gets to a deployment workflow? How do we shift security left and automate the process of scanning our code for common weaknesses and potential exploits, right inside the pull request? That requires moving up the stack, from securing the delivery to securing the code itself, using GitHub's integrated advanced security and code scanning suite. And this is where the game completely changes, because for decades, security was something that happened after the fact. It was a gate, a final, often painful review process that happened right before release, discovering critical issues when the pressure to ship was at its absolute peak. It was a team of specialists in a different department, speaking a different language, who would swoop in, find problems, and throw the code back over the wall, grinding everything to a halt. We've all lived that nightmare. The frantic, late-night scramble to patch a vulnerability found by a penetration test, just hours before a major launch. That model is broken. It's slow, it's expensive, and in the age of continuous delivery, it's dangerously obsolete. The modern approach, the philosophy that underpins GitHub Enterprise, is called shifting left. It means moving security from the very end of the line to the very beginning. It's about building security into the development process itself, empowering developers with the tools to write secure code from the first line. This isn't about making developers security experts. It's about giving them an expert Copilot. And that Copilot is GitHub Advanced Security. Let's break down what this suite of tools actually does, starting with the absolute powerhouse, CodeQL-powered code scanning. Imagine you could take your entire codebase, every function, every variable, every library call, and represent it as data, a queryable database. Now imagine you could write queries against that database to find specific patterns. Not just simple text searches for a bad function name, but complex semantic queries that understand the flow of data through your application. A query that asks, show me every place where user-provided input can reach a database query without being properly sanitized first. That, in a nutshell, is CodeQL. It's a revolutionary static analysis engine, born out of years of research at Oxford University and acquired by GitHub, that treats your code as data. This allows it to find vulnerabilities with a level of accuracy that traditional tools can only dream of. We're talking about the really nasty stuff: SQL injection, cross-site scripting, remote code execution, insecure deserialization, the kind of vulnerabilities that make headlines. GitHub's own security research team, along with the open source community, maintains a massive library of these CodeQL queries, covering the most common and critical weakness enumerations. Here's how it works in practice and why it's so seamless. A developer works on a new feature and opens a pull request. As part of your CI checks, a CodeQL analysis is automatically triggered. It scans the changes, and if it discovers a potential vulnerability, say that potential SQL injection we mentioned, it doesn't just fail the build. It posts a comment directly on the offending line of code inside the pull request, with an alert. This alert explains exactly what the vulnerability is, why it's a problem, and often how to fix it, sometimes with a specific code suggestion. The developer never has to leave GitHub. They see the feedback, fix the code in the same branch, push the change, and the scan runs again. The feedback loop is reduced from weeks to minutes. It transforms security from a confrontational gatekeeper into a helpful, automated mentor. Next up is secret scanning. This one is brilliantly simple and incredibly effective. Every single US-based company I've ever worked with runs on a mountain of secrets. API keys, access tokens, private certificates, database connection strings. And one of the most common and most terrifying security mistakes is accidentally committing one of these secrets into a Git repository. Once it's in the commit history, it's effectively compromised, especially if it's a public repository. The race is on to revoke the key before a malicious bot sniffs it out, which can happen in seconds. GitHub Secret Scanning is your automatic safety net. It runs on every push and scans for patterns that match secrets from over 100 different service providers. We're talking AWS keys, Azure credentials, Google Cloud tokens, Slack webhooks, Stripe keys. The list is exhaustive. If it finds a potential secret, it doesn't just flag it. For many providers, GitHub automatically forwards the finding to the provider, who can then take immediate action, like revoking the token and notifying its owner. This feature alone can prevent catastrophic breaches that would cost millions in damages and reputational harm. It's a non-negotiable backstop for any team operating in the cloud. The third pillar of advanced security is all about your supply chain, dependency review and Dependabot. In modern software development, we don't write everything from scratch. We stand on the shoulders of giants, using thousands of open-source packages and libraries. But this creates a new risk. What if one of those dependencies has a known vulnerability? Your application is now vulnerable too. This is the heart of supply chain security, and it's a top concern for C-suites and federal agencies alike, especially after incidents like Log4j sent shockwaves through the industry. Dependabot continuously monitors your dependency files, your package.json, your requirements.txt, your pom.xml, and cross-references the versions you're using against a massive database of known vulnerabilities. When a new vulnerability is disclosed for a package you use, Dependabot automatically opens a pull request on your repository to upgrade to the patched version. It's incredible. You get a clear description of the vulnerability and test results from your CI pipeline to ensure the upgrade doesn't break your build. Your team just has to review and merge. It takes the manual, tedious, and error-prone work of dependency management and automates it. Dependency review takes this a step further, bringing it right into the pull request. When a developer adds or updates a dependency in a PR, you'll see a rich diff that clearly shows what's changed, the license of the new package, and whether it has any known vulnerabilities. It allows you to catch a problematic dependency before it ever gets merged into your main branch. When you combine these three tools, code scanning, secret scanning, and dependency management, you create a powerful multi-layered defense, all automated and integrated directly into the developer workflow. And for US-based teams, especially those in regulated industries like finance, healthcare, or government contracting, this is more than just good practice. It's a critical component of your compliance posture. Having an auditable, automated record of security scans on every single pull request is invaluable for things like SOC 2 or FedRAMP compliance. It demonstrates a mature, proactive security process. It proves you're not just ticking a box. You're building security into the very fabric of how you create software. This approach doesn't slow developers down. It speeds them up by preventing costly rework and last-minute emergencies. It allows your senior security engineers to focus on higher-level architectural risks instead of chasing down common implementation errors. It's a force multiplier for your entire engineering organization. So now we've secured the platform with robust authentication and access controls. We've secured the delivery pipeline with protected branches and status checks. And now, with advanced security, we're securing the code itself automatically and continuously. But securing the code is one thing. How do we manage and enforce these security standards consistently across an entire enterprise with potentially thousands of repositories and hundreds of teams? How do we give security and compliance teams the visibility they need without becoming a bottleneck? That requires a system of enterprise-level governance and policy. This is where GitHub Enterprise shifts from being just a code hosting platform to a true enterprise command center. The concept is simple, but its execution is profound. Establishing guardrails, not gates. The goal isn't to slow developers down with bureaucratic red tape. It's to create a paved road, a safe and efficient path where they can move at maximum velocity without accidentally driving off a cliff. It all starts at the very top with enterprise-level policies. Think of this as the constitution for your entire software development ecosystem. These are the big, non-negotiable rules that apply to every single organization, every team, and every repository under your purview. For most US companies, especially those in regulated industries like finance, healthcare, or government contracting, the first policy you'll set is disabling the creation of public repositories. It's a simple toggle, but it instantly eliminates a massive category of risk. Another foundational policy is enforcing two-factor authentication across the entire enterprise. In today's threat landscape, a password alone is a welcome mat for attackers. By enforcing 2FA at the enterprise level, you ensure a baseline of security for every single user account, from the CEO to the summer intern. These high-level policies are your first line of defense, but true governance requires more nuance. Not all parts of your business have the same risk profile. The code for your public-facing payment processing system needs a different level of scrutiny than the code for an internal cafeteria menu app. This is where organization-level policies come into play. You can create different organizations within your enterprise, say core financial services and internal tools, and apply different sets of rules to each. Inside the financial services org, you might mandate that all repositories must have branch protection rules enabled on their main branch, preventing anyone from pushing code directly without a pull request and a required review. You could enforce specific security settings, like requiring all new repositories to have Dependabot and code scanning enabled by default. Meanwhile, in the internal tools org, you might have more relaxed policies to encourage rapid experimentation. This layered approach allows you to tailor your governance to match the risk, giving you precision control. But let's get down to the code level where the real magic happens. This is the world of repository rule sets. If enterprise policies are the constitution, repository rule sets are the specific, actionable laws that govern day-to-day development. This is one of the most powerful features in GitHub Enterprise, transforming abstract policies into real-time feedback for your developers. Instead of a long, forgotten document on a company wiki that says, all commit messages must include a Jira ticket number, you can create a repository rule set that enforces this. A developer tries to push a commit with a message like fix the bug. The push is rejected, right in their terminal with a clear message. Commit message must match regex pattern, 8 plus 0 to 9 plus. Suddenly, the policy isn't a suggestion. It's an automated, helpful part of their workflow. You can prevent commits that include files larger than 5 megabytes, stopping bloated assets from ever entering your history. You can mandate that all commits must be signed with a GPG key, providing a cryptographic guarantee of the author's identity, a critical requirement for high-security environments and something that helps prevent supply chain attacks. The best part is that these rule sets can be applied dynamically. You can target all repositories in an organization, or only repositories with a specific tag, like production critical. You can even set a rule set to evaluate mode, where it just warns developers of violations without blocking them, allowing you to roll out new policies gradually without disrupting work. This is policy as code in its most practical form. It's auditable, scalable, and it meets developers where they are. Now let's talk about the things that keep CISOs up at night. Secrets in code and vulnerable dependencies. GitHub Enterprise tackles this head-on with a suite of advanced security tools. First up is secret scanning. We've all heard the horror stories. An engineer accidentally commits an AWS access key to a repository. Before they even realize it, bots scouring the internet have found it and are spinning up crypto mining instances on their company's dime. GitHub secret scanning actively scans every single push, in real time, for a massive list of known secret formats from providers like Amazon, Google Cloud, Slack, and Stripe. But what makes the enterprise version so powerful is two things. First, push protection. It doesn't just tell you after the fact that a secret was committed. It can actively block the push from ever happening. The developer gets immediate feedback, right in their command line, that they're about to make a huge mistake. It's a proactive shield. Second is the ability to define custom patterns. Maybe your company has a unique internal API key format. You can teach GitHub Scanner to recognize it. You provide a regular expression, and now your custom-built secrets are just as protected as a standard AWS key. This is a game changer for preventing costly, embarrassing leaks. Next is the supply chain. Your code isn't just your code. It's a complex web of open-source dependencies. A single vulnerability in a small forgotten library can compromise your entire application. Think of the Log4j crisis. It sent companies scrambling for weeks. GitHub Enterprise provides Dependabot, an automated system that constantly monitors your dependency files, your package.json, your pom.xml, your requirements.txt. When it finds a known vulnerability in one of your dependencies, it doesn't just alert you. It automatically opens a pull request with the fix, updating the library to a safe version. Your team just has to review the PR, run the tests, and merge. It's like having a dedicated security engineer for every single one of your repositories, tirelessly patching vulnerabilities. Finally, for governance, you need visibility. You need proof. This is the role of the audit log. The audit log in GitHub Enterprise is the definitive, immutable record of everything that happens across your entire instance. Who cloned a critical repository at 2 a.m. on a Sunday? Who changed a branch protection rule? Who added a new user to a team with administrator privileges? It's all there. The log is incredibly detailed, searchable, and most importantly, streamable. You can pipe this data directly into your company's security information and event management system, your CM, like Splunk or Datadog. This allows your security operations team to correlate GitHub activity with other signals from across the company, building a complete picture of your security posture and detecting potential threats in real time. For any U.S. company that needs to comply with regulations like SOC 2, HIPAA, or FedRAMP, this comprehensive, easily accessible audit log isn't just a nice-to-have. It's an absolute requirement. Putting it all together, this system of policies, security scanning, and auditing creates a powerful feedback loop. You set policies with rule sets, you protect the code with secret scanning and Dependabot, and you verify everything with the audit log. It's a holistic approach that allows you to confidently answer the tough questions from your board, your customers, and your auditors. You're no longer just hoping that your teams are following best practices. You are systematically ensuring it, all while providing tools that actually help developers move faster and write more secure code from the very beginning. But with this fortress of policy and security in place, a new question arises. How do we know it's working? How do we measure the productivity of our teams, identify bottlenecks, and truly understand the health of our software development lifecycle? That requires moving beyond governance and into the world of deep, actionable insights. And this is where the rubber truly meets the road, because having all the best tools, the most secure pipelines, and the strictest compliance policies means very little if you're flying blind. The world's most successful development teams don't just feel like they're being productive. They know it. They measure it. They obsess over it. This is the final crucial layer of the GitHub Enterprise ecosystem. The ability to turn your team's activity into a clear, data-driven narrative of your engineering health. Starts with the basics. Inside every repository, you have access to Pulse and contribution graphs. Think of these as the EKG of your project. Pulse gives you a snapshot, a quick, digestible summary of pull request activity, open and closed issues, and contributions over the last week. It's the first place you look to see if the project's heart is still beating. Contribution graphs zoom out, showing you the peaks and valleys of activity over time. Are we more productive on Tuesdays? Did that big holiday week really slow us down? It's simple visual feedback. But for enterprise teams, especially in the hyper-competitive US market, simple feedback isn't enough. We need to speak the language of the business. We need to talk about velocity, stability, and efficiency. And that's where we graduate to the gold standard of engineering metrics, DORA. DORA stands for DevOps Research and Assessment, and it provides 4 key metrics that have been proven to correlate with high-performing organizations. GitHub Enterprise doesn't just talk about DORA. It helps you measure it right out of the box. First, there's deployment frequency. How often are we successfully releasing code to production? Are we deploying multiple times a day? Or are we stuck in a monolithic once-a-quarter release cycle? A higher frequency means you're delivering value to your customers faster and iterating more quickly than your competitors. GitHub Actions makes this metric transparent. Every successful deployment workflow run can be tracked, giving you a clear picture of your release cadence. Second is lead time for changes. This is the time it takes for a commit to get into production. A developer writes a line of code. How long does it sit in a pull request? How long does it wait in a staging environment? How long does it take to finally reach the user? A long lead time is a symptom of a bottleneck. Maybe your PR reviews are too slow. Maybe your CI/CD pipeline is clogged. GitHub Enterprise allows you to see this entire lifecycle, from commit to merge to deployment, helping you pinpoint exactly where the friction is. Third, we have the change failure rate. Of all the deployments we make, what percentage of them cause a failure in production? A high failure rate means you're moving too fast without enough quality control. It erodes customer trust and burns out your team fighting fires. By integrating your incident management tools with GitHub, you can correlate deployments with production issues, giving you a stark, honest look at the quality of your releases. Are failures spiking after a certain team's deployments? Is a specific part of the codebase notoriously fragile? This metric tells you where to focus your testing and quality assurance efforts. And finally, there's time to restore service. When a failure does happen, and it will, how long does it take to recover? A high-performing team can detect, diagnose, and resolve an issue in minutes, not hours or days. This is where the entire platform comes together. A developer can see the issue, create a hotfix branch, get it reviewed, pass all automated checks and actions, and deploy a fix with incredible speed, all within a single unified workflow. Tracking this metric shows you the resilience of your system and your team. These 4 DORA metrics are not just numbers on a dashboard. They are the language that translates engineering activity into business outcomes. When you can walk into a boardroom and say, "We've reduced our lead time for changes by 40%, allowing us to ship critical features a full 2 weeks ahead of our main competitor," you are demonstrating undeniable value. But the insights don't stop at DORA. Remember GitHub Advanced Security? The analytics here are just as critical. The Security Overview dashboard gives you a command and control view of the risk across your entire organization. How many high-severity vulnerabilities do we have right now? Which repositories are the most at risk? Are our teams actually fixing the alerts that code scanning generates? Or are they just letting them pile up? You can track the average time to remediate a vulnerability, turning security from a reactive chore into a proactive, measurable part of your development culture. This is how you prove compliance. This is how you prevent the next catastrophic data breach. And what about cost? Every engineering leader in the US is being asked to do more with less. GitHub Actions, while incredibly powerful, consumes resources. The platform provides detailed usage metrics, allowing you to see exactly which teams, repositories, or workflows are using the most CI/CD minutes. You can identify inefficient builds, optimize your runners, and ensure your investment is being used effectively to drive business value, not just to run redundant tests. Let's put this all together into a story. Imagine a team that's struggling. Deadlines are being missed. The product feels buggy. Morale is low. Management's instinct is to blame the developers for being slow. But that's just a gut feeling. Now let's give that team GitHub Enterprise insights. They look at their DORA metrics and discover their lead time for changes is a staggering 15 days. They dig deeper. They see that the average pull request sits waiting for review for over a week. The problem isn't slow developers. It's a broken review process. So they implement a new policy using the code owner's file to automatically assign reviewers. They set up reminders for stale PRs. 2 months later, they look at the data again. Their lead time for changes is down to just 3 days. Because they're shipping smaller changes more frequently, their change failure rate has also dropped. The developers are happier because their work is getting merged and shipped, not sitting in limbo. The product is more stable. Management is thrilled because features are being delivered on schedule. They didn't work harder. They worked smarter. They replaced blame with data. They identified the real bottleneck and fixed it, and they had the numbers to prove their success. That is the transformative power of these insights. And for the most sophisticated organizations, it goes even further. GitHub Enterprise has a rich API that allows you to pull all of this data. Every commit, every pull request, every security alert, every workflow run, into your own business intelligence tools. You can build custom dashboards in Grafana or Tableau, correlating engineering data with sales figures, customer support tickets, and other business KPIs to get a truly holistic view of your company's performance. So let's zoom all the way out. Over these 10 parts, we've journeyed through an entire ecosystem. We started with the foundation, a secure, scalable central home for your code. We built upon that with world-class collaboration tools that foster a culture of transparency and shared ownership. We automated everything that could be automated with GitHub Actions, creating fast, reliable pipelines for building, testing, and deploying our software. We wrapped it all in a blanket of security with tools that shift security left, making it everyone's responsibility from the very first line of code. We managed our dependencies, governed our organization with enterprise-grade policies, and ensured we were compliant with industry standards. And finally, we learned how to measure it all. How to turn the chaotic, creative process of software development into a clear, predictable, and constantly improving engine for innovation. GitHub Enterprise is more than just a tool. It's a strategic platform. It's a cultural shift. It's the difference between a company where development is a mysterious cost center and one where it is the undeniable driver of growth and competitive advantage. In the end, the code your teams write is the most valuable asset your company owns. The platform you choose to build, secure, and deliver that code shouldn't just be a utility. It should be your single greatest strategic investment in building the future.